A black hole is a superdense object in space from which no light can escape. While black holes seem enigmatic and exotic, they are also an important consequence of how gravity works. When a large amount of mass is compressed into a tiny enough region, the resulting object rips the very fabric of space and time, forming what is known as a singularity. A black hole's gravity is so strong that it can draw in neighboring material and eat it. 1. How can we learn about black holes if they trap light and can't actually be seen? No light of any kind, including X-rays, can escape from inside the event horizon of a black hole, the region beyond which there is no return. NASA's telescopes that study black holes are looking at the surrounding environments of the black holes, where there is material very close to the event horizon. Matter is heated to millions of degrees as it is pulled toward the black hole, so it glows in X-rays. The immense gravity of black holes also distorts space itself, so it is possible to see the influence of an invisible gravitational pull on stars and other objects. 2. How long does it take to make a black hole? A stellar mass black hole, with a mass of tens of times the mass of the Sun, can likely form in seconds, after the collapse of a massive star. These relatively small black holes can also be made through the merger of two dense stellar remnants called neutron stars. A neutron star can also merge with a black hole to make a bigger black hole, or two black holes can collide. Mergers like these also make black holes quickly, and produce ripples in spacetime called gravitational waves. More mysterious are the giant black holes found at the centers of galaxies, the supermassive black holes, which can weigh millions or billions of times the mass of the Sun. It can take less than 1 billion years for one to reach a very large size, but it is unknown how long it takes them to form, generally. 3. How do scientists determine the mass of a supermassive black hole? The research focuses on the movements of stars in galaxies' cores. These motions imply a dark, enormous body whose mass may be calculated from the velocity of the stars. Matter that falls into a black hole contributes to its mass. Its gravity persists throughout the universe. 4. Can a black hole eat a whole galaxy? No. There is no way a black hole could consume a whole galaxy. The gravitational reach of supermassive black holes located in the center of galaxies is immense, but not quite large enough to consume the entire galaxy. 5. What happens if you go into a black hole? It would surely not be good. However, what we know about the inside of black holes is based on Albert Einstein's general theory of relativity. For black holes, distant onlookers will only perceive regions outside the event horizon, whereas individual observers plunging into the black hole will experience a completely different reality. If you enter the event horizon, your view of space and time will completely shift. At the same time, the black hole's massive gravity would compress you horizontally while stretching you vertically like a noodle, which is why scientists name this phenomena, no joke, spaghettification. Fortunately, this has never occurred to anyone. Black holes are too far away to pull in any. 6. What if the Sun became a black hole? The Sun will never become a black hole because it is not large enough to explode. Instead, the Sun will become a dense star remnant known as a white dwarf. However, if the Sun suddenly became a black hole with the same mass as it does now, the planet's orbits would be unaffected since its gravitational impact on the solar system would remain constant. As a result, Earth would continue to orbit around the Sun without being drawn in, however a lack of sunlight would be terrible for life on Earth. 7. Do black holes have any effect on our planet? A big star explodes, leaving behind stellar mass black holes. These explosions release materials required for life into space, such as carbon, nitrogen, and oxygen. Mergers between two neutron stars, two black holes, or a neutron star and a black hole disseminate heavy atoms that may eventually form new planets. The shock waves from stellar explosions may potentially result in the development of new stars and solar systems. So, in some ways, we owe our existence on Earth to long-ago explosions and collisions that created black holes. On a bigger scale, most galaxies appear to contain supermassive black holes at their cores. 8. What is the most distant black hole ever observed? The most distant black hole ever discovered is in a galaxy roughly 13.1 billion light-years from Earth. The universe's age is today calculated to be 13.8 billion years, thus this black hole existed approximately 690 million years after the Big Bang. Astronomers refer to this supermassive black hole as a quasar, since vast amounts of gas are streaming into it so quickly that the energy output is 1,000 times larger than that of the galaxy. Its extraordinary brightness allows astronomers to detect it from such far distances. 9. If nothing can escape a black hole, will the entire universe be eaten up? The universe is a huge place. In particular, the area of a region where a specific black hole exerts considerable gravitational pull is quite small when compared to the size of a galaxy. This also applies to supermassive black holes, such as the one found in the center of the Milky Way. This black hole has most likely already eaten most or all of the closest stars, whereas stars further out are mainly safe from being sucked in. Since this black hole currently weighs a few million times the mass of the Sun, swallowing a few more will only result in tiny increments in its mass. 10. Can black holes become smaller? Yes. The late physicist Stephen Hawking theorized that while black holes grow larger by eating material, they also gradually shrink due to the loss of minuscule quantities of energy known as Hawking radiation. Hawking radiation occurs because empty space, or the vacuum, is not truly empty. It is actually a sea of particles that are constantly popping in and out of existence. Hawking demonstrated that if a pair of such particles is generated near a black hole, one of them may be drawn into the black hole before it is annihilated. In this case, its mate will escape into space. The energy for this comes from the black hole, hence the black hole gradually loses energy and mass.